So in this demo, I'm going to be a quality measure developer working for a professional society, and I'm going to investigate an inpatient quality indicator. In this case, I want to look at a quality indicator for C-section deliveries and the quality of care delivered associated with those deliveries. The first thing I'll do is I'll import the Rhino Health SDK. It's a Python library that has all the functions for Federated Biostatistics. I'll then authenticate onto the platform using my credentials. Next, I'm going to identify all of the data that I'm going to use. As always, the data stays on the edge. And so in this case, there's 8 hospitals contributing data to my analysis. And I've gone and identified them here and allowed the Rhino client to say, okay, this is the data that we're going to use in this analysis. So we can start off with a basic analysis. The first thing we're going to look at is how many encounters are spread across the 8 hospitals included in this analysis. So I can see quickly 30,000 childbirth encounters. And again, what's happening is all data staying on the edge. All that's getting passed to me as the data user are high-level statistics. So now let's go ahead and calculate the quality measure across the hospital. So we've created this nifty little function called calculate quality measure that takes as input a Rhino Health session, the dataset IDs that we've identified here, and finally the patient outcome of interest. And my outcome of interest here is hysterotomy. And so I'll add that, and then we'll see the overall quality measure rate across the 8 hospitals is 94%. And we see when we calculate the quality measure within each hospital and then take the mean of those quality measures, we get a similar number, and we can calculate a standard deviation as well. So let's visualize that data. So again, what we've done here is we've calculated the quality measure within each facility. And we can see the distribution is pretty uniform, but there is one outlier, this hospital 5. So one of the data contributors is hospital 5, and they have quite a much lower quality rate than other facilities. So I'm going to perform a reliability analysis in the measure development world. This is called the signal to noise ratio. Here we're using the embedded binomial model, which is a little bit bespoke to quality measure development, but we're going to go ahead and run that here. We're going to calculate the signal to noise ratio, and it comes back as 0.7. So because that's close to 1, and 1 means that the difference in the quality measures is reflective of true variation, we can see that the variation in our quality measure reflects true variation and not random chance. Okay, so now let's look at measure score difference. What we look at measure score difference is we're going to stratify our quality measure by race and ethnicity in this case. I'm going to go ahead and do that. Okay, so we're returning some statistic that identifies, for example, all African American women across my data set, again, across those 8 hospitals, and creates a pooled estimate of the quality measure among all those individuals. And we can see the visualization here. We can see that the quality measure is significantly lower among African Americans. So now we want to perform some hypothesis testing. And the biostatistical method that we're going to use here is a chi-square goodness of fit. In other words, is this difference reflective of true variation, or is it just a chance occurrence? And so we're going to go ahead and compute chi-square now using the Rhino Health SDK function chi-square. And okay, I can see that it yielded a significant p-value. So it does seem that there's real differences in the quality measure. Let's also do this with the age of the mother. So different than this variable, which is categorical, we're now looking at the relationship between our patient outcome and a continuous variable, which is age. And so we're going to use a two-sided t-test here. And again, we're going to use the Rhino Health SDK function called t-test to calculate that p-value. And we see that there is a significant difference in the relationship between age and our patient outcome, hysterotomy. So now we can do validity testing. We're going to look at the correlation between our patient outcome and let's say another patient outcome called labor complications. So this is an analysis type we're often going to do when we're looking at healthcare process measures. So I can do that here. I'm doing a couple different things. I'm calculating the quality measure by group as I did above. I'm performing a chi-square test. And then I'm going to generate a correlation coefficient to see if the hospital quality rates for my childbirth outcome is associated with labor complication rates. Okay, so I've looked at a basic difference among women with and without labor complications. I've done a chi-square test. And then finally, I looked at, for the validity testing, the Pearson correlation statistic between the two quality measures at each hospital, each of the 8 hospitals, of course.